Katie, Lynn, and Micah also our team. Presentations about steady state operating curve and step response. The outline, first I'm going to go over the system overview, then go over the steady state operating curve and how it's generated. And then I'll go into the step response, give an example of the slide, and then cover the results for it. Here's a system diagram. We put our input in here, and it goes to over to here where it's put into the motor for the input percentage. As motor spins, the generator produces an output voltage, which goes on. That voltage is recorded here, sent back to the computer, and recorded. Here's a block diagram of our system, where we specify our motor input speed, goes into the voltage system, and we get our control output as the output voltage. Here's an example of one of our steady state graphs. This was done at 80% input speed, and we see it takes 10 seconds where we get our steady state, and then the data was taken from where it went steady state on. We just took the mean output voltage from there. Here's an example of the calculation just to determine the average output voltage and then the standard deviation. And from that slide, the experiment I showed you earlier.
Yeah, there you go.
That would generate one point on here where we had the motor input speed versus the output voltage. And in our group, we had 65% motor speed to 80% was our range. And we didn't achieve steady state until 70% input motor speed. And from then, we to 80 and beyond was steady state operating. Here's an example of our step response, where we ran the motor until it reached steady state. Then we changed it up 15% from 65 to 80 to get, and we see this is a control variable, how much the output voltage changed during the step. From this, we calculated how much the control variable changed from here to here. Took 62% of that and drew a dotted line over to the steepest point and down. From there to where this dotted line crossed, there was a slope at the steepest point, would be our time constant. And then the dead time was from the time where we put the input in to where the dashed line that represents the slope at the steepest point is. Here's the results from that, where our from an entire range from 65 to 80% motor speed, we had jumped 56 volts. We had, it was a 15% increase in motor speed when our time constant 4 seconds, dead time of 2 seconds, and then a gain of 3.73. And summary conclusions, our range was from 65 to 80% input motor range, which gave us our output voltage from 10 to 70 volts. And here's the results from our step over the entire range with dead time 2 seconds, time constant 4 seconds, and the K of 3.73.
So,
Yeah.
Joel is next.